Good afternoon. Today we will discuss the topic of logic gates. Now first we see what is logic gates. Logic gates are nothing but it is a basic building block of digital electronic circuit and used in many digital electronic devices as a basic component. Okay. Now there are different types of logic gates. It is divided into three parts. First is basic gates, second is universal gate. Now we will see all the gates one by one. First is basic gate. There are three main types of basic gate. First one is NOT gate. NOT gate gives the complement output of any given input. That means we are giving, if 0, then it gives output as a 1, and if we are giving 1, then it gives output as a 0. Since all the logic gates works on only zeros and ones, then it will produce the output according to the input. Okay, we will see the now NOT gate. The NOT gate consists of only single input and it produces a single output. If we give input as a, then it produces output y equals to a bar. Now this is a symbol for NOT gate. Next, truth table for NOT gate. In truth table we have input and output. Here it consists of only single input, hence if we give 0 as an input, then it produces 1 as at the output, and if we gives 1 at the input, then it gives 0 at the output. Hence the equation for NOT gate is y equals to a bar. This is the first type of basic gate. Now we will see second gate. Second is AND gate. Now AND gate consists of two inputs and single output. If we give, first we will see the symbol of AND gate. It consists of two or more inputs and produces a single output. Then we will see the truth table for AND gate. The AND gate consists of two inputs A and B and produces the output Y. Here the combination for two input is 0 0, 0 1, 1 0 and 1 1. The main use of AND gate is it is used for multiplication of two inputs. That means it produces the multiplication output. Then multiplication of A into B is 0 0 0 into 0 is 0, 0 into 1 is 1, 1 into 0 is 0 and 1 into 1 is 1. Hence the equation for AND gate is y equals to A into B. A into B. Now next we will see third gate OR gate. The function of OR gate is it is used for addition of 2 bits, 2 or 3 bits. The symbol for OR gate is looks like this one. Here we give input A and B and it produces output Y. Now we will see the truth table. Now the truth table consists of input and output section. Here input is A and B and output is Y. If we give 0 0, then OR gate produce the addition as 0 plus 0 is 0. Then 0 plus 1, it gives 1. Then 1 plus 0, it gives 1, and 1 plus 1, here we get 1 as a output. Means OR gate perform the addition of two inputs. Okay, hence the equation for OR gate is y equals to A plus B. Now next one is, these are the three types of basic gates. First one is NOT gate, which performs the complement of input. Then second one is AND gate, which gives the multiplication of inputs at the output. And the third one is OR gate which gives addition at the output. Now next we will see the universal gate. Universal gates are those gates which are used to make other logic gates. Now NAND and NOR gate are the universal gates. First we will see NAND gate. Universal gates are used to derive other gates such as AND or NOT, basic gates, or XOR and XNOR, which are derived gates. First we will see NAND gate and then we will see the NOR gate. NAND gate is complement of AND gate. That means it is followed by NOT gate. The symbol for NAND gate looks like this. Here it shows the AND gate and this bubble shows the NOT gate. Now it produces the equation y equals to multiplication of two bits a and b and complement of this, that is a into b bar. Now the truth table for NAND gate, inputs are a and b and output is y. Here input a b combination has 0 0 0 1 1 0 and 1 1. Here it produces the output as a complement. 0 into 0 is 0, but complement of 0 is 1. Next 0 into 1 is 0 and complement of 0 is then next 1. Then 1 into 0 is 0 and complement of 0 is also 1. 1 into 1 is 1 and complement of 1 is 0. Hence it produces the total opposite operation of AND gate. The second time we will see the NOR gate. NOR gate is OR gate followed by NOT gate. Okay, that means it gives the total complement output of OR gate. The symbol for NOR gate looks like this. Here it shows the symbol for OR gate and this bubble shows the NOT gate. Now the truth table for NOR gate, and it produces the output equation as y equals to addition of two inputs and complement of that a plus b bar. Truth table inputs and outputs. Here input is a and b. It has combination 0 0 0 1 1 0 and 1 1. Now the output is y. Here it gives the output as addition and complement. Then 0 plus 0 is 0 and its complement is 1. 0 plus 1 is 1 and its complement is 0. Next 1 plus 0 is 1 and its complement is 0. 1 plus 1 is also 1 and its complement is 0. Here it is, this truth table shows the total inverse or complement of OR gate. Now next type is, last one is derived gates. The derived gates are NAND NOR, also known as the derived gates, but they are popular as a universal gate. Now derived gates, here are two types of derived gates. First one is XOR gate and second one is XNOR gate. These both are four types of derived gates: NAND, NOR, XOR, XNOR. But NAND and NOR are also known as universal gate. So we have considered only two gates as a derived gates, XOR and XNOR. They are known as derived gates because they are derived from the basic gates. Okay. First we will see the XOR gate. The XOR gate is EX stands for exclusive. Now the symbol for XOR gate is look like this. Inputs are A, B and C and equation is y equals to A XOR B, or we can write it as A bar B plus AB bar. Now we will see the truth table for XOR gate. Here it consists of inputs and output section. Inputs are A and B and output is Y. Now A and B has combination as 0 0, 0 1, 1 0 and 1 1. The property of XOR gate is that it produces the high output only for even odd combinations of input. That means one should be 0 and one should be 1. One input should be 0 and one input should be 1. Hence it produces 0, 0 for 0 0 it produces 0, for 0 1 it produces 1, for 1 0 it produces 1 and for 1 1 it produces 0. That means it produces high output only for the odd combination of inputs. Now the last one we will see the XNOR gate. XNOR gate is XOR gate followed by NOT gate. Here this is a symbol for XNOR gate. It looks like XOR gate, only the difference is it consists of a bubble which is nothing but the NOT gate. Now it produces the output equation as Y equals to A XNOR B. XNOR symbol is look like this. This means A bar B bar plus AB. And the truth table is input and output section. Inputs are A and B and output is Y. The combination for A and B is 0 0 0 1, 1 0 and 1 1. Here as we know XOR gate produces high output only for odd combination of inputs, but XNOR gate is totally opposite of XOR gate. Hence it produces high output for even combination of inputs. That means if both the inputs are same, it produces output as a 1. That means for 0 0 it produces 1, for 0 1 it produces 0, for 1 0 it produces 0 and for 1 1 it also produces 1. Hence these are all the types of logic gates which are used in digital electronic circuit for basic operations, and it is useful in many digital devices. Thank you.